Okay, so today we are going to start our new topic in quadratic polynomials, that is graph of the quadratic polynomial. So our next topic is that is graph of the quadratic polynomial. Okay, now for drawing the graph of the quadratic polynomial, let us look at what are the various parameters on which the graph of the quadratic polynomial depends. So basically, what are the parameters? First of all, we just write down the general expression for a quadratic polynomial, that is p of x is equals to ax square plus bx plus c, where a should not equals to 0. That is the general expression for a quadratic polynomial. Now the graph of the quadratic polynomial depends on four parameters. One is sine of a, sine of b, sine of c, as well as value of the discriminant of the quadratic equation. So let us define one more parameter, that is discriminant of the quadratic equation, that is d is equals to b square minus 4ac. That is the discriminant of the quadratic equation. Now how the graph depends on these parameters, we look at one by one. First, okay, the sine of a. Let us look at how the graph of the quadratic polynomial depends on the sine of a. Okay, here we consider the two cases. If we have a is if a is greater than 0, if value of a comes out to be positive, then the graph of the quadratic polynomial depends how the shape of the quadratic polynomial will be. Since we are aware of the fact that the graph of a quadratic polynomial is a parabola, so it will opens upward. Opens upward means if sine of a is positive, then the graph of the quadratic polynomial will opens upward. And if we consider the second case, if a is less than 0, okay, in this case it will opens downward. It will opens downward. Now let us move on. Means if we graphically represent these two situations, we can present them like this. If the graph is opens upward, means it will look like this. Okay, if it opens downward, then it will look like this. Okay, these are the two forms for the parabola. Then again, next we move to again the sine of the c. Now how the graph depends on the sine of the c, that is our next. So second we can write that is sine of a. Sine of. Okay, here again we consider the two cases. If sine of c is positive, means value of c is greater than 0, then we can write the graph. Then the graph will cut. Then graph will cut y-axis. Then the graph will cut y-axis on positive side. On positive side means if sine of c is positive, then the graph will cut the y-axis on positive side. And second case, if c is less than 0. If c is less than 0, then we can see in the graph, then the graph will cut y-axis negative side. On negative side. These are the two cases. Okay. If we want to represent these two situations graphically, this can be represented like this. Like this. How these situations can be represented? In the first case, if c is greater than 0, then it will look like this. Okay, this is the y-axis and this is the x-axis. Okay, so graph will be like this. That is the case for c is greater than 0. In the similar way, second case, If c is less than 0, then graph can be like this. Okay, it will cut on negative side of the y-axis. That is the case for value of c is less than 0. Now we come to the next parameter, how the graph of the quadratic polynomial depends on the sign of d. So our third parameter is, that is sign of, that is sign of d, sign of d. Now how the graph of the quadratic polynomial depends on sign of d, we look at the three cases mainly. What are the different cases? First, in the first case, if d is greater than 0, let us look at the first. If d is greater than 0, if d is greater than 0, then the graph of the quadratic polynomial will cut, then it will cut, then it will cut x-axis, then it will cut x-axis at two distinct points, at two distinct. Okay, and if we graphically draw this situation, we can draw it like this. The graph will look like this. Graph will cut the x-axis at these two distinct points. And these are the roots of the quadratic polynomial, alpha or beta. Okay, so it is our first situation when the value of d is greater than 0. Now we come to our second situation. If sign of d is equals to 0. So in second case, we say if sign of d is less than 0. If d is less than 0, then sorry, we were discussing the situation if sign of d is equals to 0 or value of d comes out to be 0. Okay, in this situation we are saying if d is equals to 0, then it will touch, then it will touch at 2, then it will cut, then it will touch at, then the graph of the quadratic equation will touch the x-axis, will touch the x-axis at equal point, at equal point. If we want to draw this situation graphically, how can it be represented like? It can be represented like this. So x-axis and the graph will touch the x-axis at two equal points where alpha is equals to beta. Means in this case the polynomial will have two roots. Now in the third case, now we come to a third case, that is if the sign of d is less than 0. Okay, so we look at our next situation, sign of third situation, that is third. Here if d is less than 0, in this condition the graph, in this condition the graph will neither cut, the graph will neither cut nor touches x-axis, neither cut nor touches x-axis. Okay, means with it will lies on the upside of the x-axis or on the downside of the x-axis. Means these situations can be represented like this, can be represented like this. The graph will be like this, or it can be like this. These are the two situations when d is less than 0. Now finally we come to the sign of b. How the sign of b affects the graph of the quadratic polynomial. So our next point is, that is how it depends on the sign of b. We can see here we consider the two cases. In the first case we can write if a is greater than 0 and b is greater than 0. If sign of both a and b are positive, a is positive as well as b is positive, then the vertex of the parabola, okay, the coordinate of the vertex of the parabola b away x belongs to minus b upon 2 minus d upon 4a. These are the coordinate of the vertex of the parabola. Okay, so how the sine of b affects the x coordinate of the vertex of the parabola. Okay, how can we represent this relation? Here we can see in this case the x coordinate, that is the coordinate of the vertex of the we know that the coordinate of the vertex of the parabola is equals to minus t upon 4. This is the coordinate of the vertex of the parabola. Now how the x coordinate depends? Here x coordinate is minus b upon 2a. X coordinate is minus b upon 2. Now here, if a is positive and b is positive, means we can write b is positive, means in numerator we can write positive sign, then 2 into any positive quantity. So overall quantity comes out to be negative. Means here we can see if the sign of b and a are of equal sign, means if both are positive or both are negative, then the x coordinate, then we can write then x coordinate will lie, we can write x coordinate will lie on left hand side of the origin, left hand side left hand side of origin. Okay, and in the second case we can write, okay, in this we can write second case, if a is positive but if b is less than 0, means a and b are of opposite signs, then in this case x coordinate minus b divided by twice of a, again we can write b is negative, means is negative and a is positive, so overall quantity comes out to be positive. So in this case we can write x coordinate x coordinate right hand side of the. Okay, so these all are the four parameters on which the graph of the quadratic polynomial depends: sine of a, sine of b, sine of c, as well as sine of d. Now let us plot the graph of the quadratic polynomial. Okay, so we can understand this by any situation. Let us take some question. Okay, so first question is, okay, draw the graph of 2x square plus 3x minus 4. Okay, draw the graph of the polynomial 2x square plus 3x minus 4. Okay, now how we can solve this? Okay, we can represent this polynomial by p of x is equals to twice of x square plus 3 times x minus 4. Now we look at the sign of here. Values of a is equals to 2, value of b is equals to 3, and value of c is equals to minus 4. And we can calculate also the value of the discriminant of the quadratic, that's d is equals to b square minus 4ac. So d is equal to b square, means that is 3 square minus 4a into c minus 4. If you solve this value, that is comes out to be 9 plus 32. The value of d is equal to 41. Means what we are interested, d is greater than 0. Okay, now here we have observed all the signs. Okay, a b c and d. Now how the graph of this polynomial can be represented? So now we come to the plotting of the graph. Okay, here we can see, since x coordinate, since a is positive, here a is positive, means graph will be like this. Okay, in second situation, c is less than 0, means graph will cut the y-axis on positive side. Okay, it will cut the y-axis on positive side. Again we see again the d, since d is greater than 0, means the graph will cut the x-axis at 2 points. It will look like this. And finally we look at the sign of the x coordinate. X is equals to minus b divided by 2a. Now here minus of b is positive, divided by twice of a is also positive. So overall quantity of x coordinate becomes negative, means x coordinate will lie on the negative side of the negative side of the origin or left hand side of the origin. Now finally, how we can plot the graph of this quadratic polynomial roughly. Okay, the graph of this polynomial will look like this. It's the origin. Okay, now how can you plot? The graph will be like this. Okay, this is the here is the vertex of the and C means it contains the y-axis on the positive side. Okay, so this is the final graph of the quadratic polynomial which was given in question. Now let us solve few more questions on the best of the graph of the quadratic polynomials. Okay, and we are given the following in this graph. In this graph, we have to tell the sign of. Let us solve this question. How can we solve this? First of all, observe the shape of this parabola. Since it opens downward, so by just observing the shape of the parabola, we can say sine of A should be less than 0 since it opens downwards. Since it opens downwards. Okay, then next we see D. Since it cuts the x-axis at 2 points, so D is greater than 0. Since why D is greater than 0? Because it cuts at two distinct points. At two distinct. Okay, then we look at the sign of C. Since it cuts the y-axis on negative side, so definitely we can write here C is less than 0 again. Okay, reason is on negative side. Then we finally come to the sign of B. Since minus B upon 2A. Here, sign of since minus B upon 2A lies on the positive side of the origin, so minus B upon 2A is positive. Now for this quantity to be positive, we can write twice of A is negative. Now negative cancel out, so definitely sign of B must be positive. Then only we can say this overall quantity is positive. So finally we can write here the sign of A, B, C and D like this. How can we write all this sign? Here A is less than 0, B is greater than 0, C is less than 0 and D is greater than 0. This is our final answer. Okay, so it's all about all graph of the quadratic